Hi everyone, Paul Tchaikovsky here from VMware. So in a previous video, I showed you how I use Kubernetes operators to install Pivotal Container Service onto Google Cloud. And that's great, it gives me Kubernetes, but it doesn't give me what I would consider a workable operations environment. I feel like if you're really going to operate software, you need to have monitoring and logging, you need to have access control, you need to have a bunch of other stuff that Kubernetes doesn't necessarily come with out of the box. The way I do that is I install them using Helm, and I wrap all of that in Helm file. So I have this Git repo, platform operations on Kubernetes. This is how I install the operations pieces onto my Kubernetes clusters. I run this multiple times a week. I'm constantly spinning clusters up and down as I'm doing demos and testing things out for work. Let's explore it a little bit. It does use Helm file, and Helm file is a way to orchestrate and do gitops type workflows with Helm charts. And so you basically wrap it around a group of Helm charts and coordinate them together. And to use what's called a Helm file, obviously, and that contains a list of Helm charts and things you want to do with them. So if we have a look at what we have in the Git repo, it's pretty straightforward. You pass Helm some defaults, you set some environments, and you can see I'm pulling from environment variables here, and this allows me to gives me some pretty good control over environment specific settings, and I'll show you how that works in a little bit. And then I'm ranging over a bunch of properties to figure out which Helm chart repositories I need to use, and then further down I'm doing another range to actually install those Helm charts. And I do it this way to make it a lot more composable and keep it pretty dry. You don't want to have a bunch of copied boilerplate over and over again. And so with GitOps, you have your source repos. This is effectively my source repo, this platform operates on Kubernetes repo. And then you have an enums repo. I'm not going to show you my actual enums repo, but I have some examples that ship with this repo. So I'll show you one of those. So there's a default one, and I have two files of importance, an enums.sh and the values file. So if you look at the enums file, it's pretty straightforward. It's a bash script that exports a bunch of environment variables. So these are specific to this environment. So from a name, the directory that this file and the values file is in. And then we start getting into some passwords and other stuff. So you can see here, obviously this is not a real password. You wouldn't use this, but in a demo environment, it works fine. And in a real environment, you wouldn't have your passwords in Git just like this. You'd have them encrypted somewhere, maybe in HashiCorp Vault or something like that. And then you could be running commands here to extract those values and use them as environment variables. And that's why I kind of chose to go down this route. So we can either have just straight out text, or we can be pulling in output from commands. And that way I can choose which config pieces I do want to store in Git and which I don't. For example, like URLs and usernames and stuff, I don't care about storing those in Git, but I don't want to store my passwords in Git. Using environment variables helps me do that. And then I have a values file, and that values file basically sets up what my Kubernetes cluster looks like. So you can see we have a set of YAML keys, one for each Helm chart, and it's the sort of things you would expect to see when you need a Helm chart, right? The name of it, namespace to install to, the chart version. If it has an external repository, like it's not coming from the Helm hub, then your repository, and then a values file. And that values file is actually templated Helm values file. And that's where we actually start configuring the individual Helm charts themselves. So if we pick one of these, I think Grafana might be a good one because it's pretty simple, if I remember correctly. So we'll go find this values file and I'll show you how that looks. You can see I have a values file for each main app, Grafana, values. So I always want persistent storage when I'm using this. And then you can see I'm starting to pull things from my environment variables. So there's my Grafana admin password for local access. You can see I set up data sources, and I'm pulling in the namespace that Prometheus is being installed to fill out the DNS for Prometheus. And that's about it. Everything else is pretty much standard across all my environments. You can see I also do things like add in some default dashboards that I pull down from the Grafana templates website. Now, if I wanted this to be vastly different, I would vendor this values file in my environment, and then I would change the location of the values file in that environment values file to point to the new location. So these are kind of the defaults through here, and they work for most of my installs. If there's something vastly different, it's easy enough to modify. That's kind of what I've been aiming for this, is to keep it fairly sane default-wise, but also make it really easy to customize for specific use cases. So that's the basics of how this works. I have two default environments. So I have two main environments. I have the default, which I was just showing you, which gives you basically most of the pieces out of the box with a default local username and password, no ingress, no internal access, no real tight authentication. And so that's if you're running it in Minikube or something small just for yourself, you might use that. But if you're actually wanting to run it for real, you want to back it with some sort of external authentication. And so I've been working on building out OpenID support using UAA. UAA is a tool that grew up in the Cloud Foundry ecosystem. And it's basically a OIDC gateway between you and your enterprise directory service. So LDAP or Active Directory or whatever you like to use. UAA sits in front of that and gives you that OpenID interface that most web apps will know how to authenticate against. So this environment will set that up across all of the apps being installed, so that whether I'm going to Kibana, whether I'm going to Grafana or to Spinnaker, I'm using the same set of credentials, and I'm inheriting roles and permissions based on things that are set in Active Directory or LDAP. So that's the crux of this repo. And now we're actually going to flip across to our code and actually start going through and actually we'll deploy a instance, and we'll check, we'll see how everything installs, and we'll see the authentication back to OIDC, etc. So let's swing back to our actual code and figure out what we need to do. So I have that branch loaded up here. I have install instructions for using it. I've done a few things here already. I've already prepared my ends file because I don't want you to see my passwords. I've already created my DNS zone, Google accounts, sort of all the precursors. I've got a Kubernetes cluster, a PKS cluster. So if we look here, see I've got a PKS cluster there, and it has four worker nodes, and it hasn't really got anything installed yet, so just the basic namespaces. So it's kind of a fresh, I haven't installed anything on it, PKS cluster, ready to have our stuff installed onto it. Helm, I already have Helm and Helm file, so we can kind of skip through that. So I need to load my environments, so let's do that. Cluster 1 ends. So that's now got all my customization for this cluster loaded up as environment variables. I have to apply some CRDs for Cert Manager, so let's go ahead and do that. While that's running. Next, each app needs a client for OIDC in UAA. So I have instructions on how to get UAA set up, how to auth against it, how to add a user, and then how to add clients. And then I have a script that will do the clients. I already have the user. So let's go ahead and run this script right here. And that'll loop through and create the clients that we need. Pretty straightforward. It's literally a copy and paste of all these commands into a script. You can see I also have a couple of other things. I haven't scripted them yet, creating some storage buckets. The instructions are all there. At some point I'll add them to scripts, or I might even figure out how to get a Helm file to do that for me as part of the install. Right now I'm sort of less interested in those specific automation pieces and more just getting everything working. So that's why I've got a few manual steps in here, but not too many. Now, if you had a self-signed certificate, there'd be a couple of other things you needed to do to make sure your certificate CA for UAA was there, so various apps would know to trust it, but I'm using a real certificate, so we can skip through that. And then with Elasticsearch, there's a couple of things you need to set on your worker nodes to make sure they're sized correctly. Realistically, any Kubernetes cluster you have should be okay to run this, but if not, you can either run this command, or you can, there's a flag in the Elasticsearch Helm chart that lets Elasticsearch do it itself if you have privilege mode enabled on your clusters. So that's kind of all the real instructions you need apart from running the Helm file command itself. And you can see here it is. I'll point at my state values file, which is that values file I was showing you, and then apply. So normally I would do a diff first, and that would just render out all the templates and look to see what needs to be installed. And that's not necessary. I just will often do it when I've changed a bunch of stuff to make sure that the templates all still render out correctly. But we'll just go ahead and run this apply command. Helm file actually does a diff as part of the install, and it only installs the things that are different. So this first install will be quite extensive. So let's clear the screen here. So there's a Helm file apply command, and so we'll go ahead and hit that off. So this is going to take probably about 15 minutes. A good chunk of that will be Spinnaker. The way Spinnaker works is it has a job that runs a tool called Halyard, and Halyard takes about 10 minutes to fully install Spinnaker, and it sort of holds up the Helm process while it does that. And that means obviously I'm not going to make you sit here and stare at a screen for 15 minutes. So I will pause the recording here and bring it back up when the install is finished. All right, you can see here that Helm file has finished. And then I just ran a couple of commands to make sure things were working. So let's clear this up and let's have a look at, first of all, you can see we now have a bunch of new namespaces. So most of those projects went into their own namespaces. Stuff like the EFK stack all went into sort of generic logging. The Grafana and Prometheus all went into a generic metrics, etc. So we can now do, say, get ingress, and I'll just do all namespaces. Oop, helps if I spell it right. So you can see we created a bunch of ingress based on our base URL, and we installed an ingress controller as part of this, as well as external DNS controller and the cert manager controller. And so that allowed us to get ingress for each of these apps, but also get encryption and also DNS registered. And that means I can basically now switch across to a web browser and start logging into some of these things. Let's go ahead and open up one of those applications and look at the login process. So we'll start with Grafana, we'll hit it up, it'll get redirected to SSL, it'll go to the login page. We'll hit sign in with UAA, and that should flip it to my UAA server. I can log in as the test user that I've created. And that will take me through to Grafana. So I'm now logged into Grafana as a user from my enterprise LDAP server. You can see there's information about my user down here, but let's go and look at dashboards. So I have some default dashboards lined up. The first of all, well, the one we'll look at is the default cluster monitoring for Kubernetes. This is available up on the Grafana dashboard site, and it is a fairly simple dashboard for PKS. So you can see basic memory, CPU usage. We can look at all the different pods that are running and what resources they're taking up. Memory, CPU, network I/O, pod, network I/O. So not a ton of information, but a sort of a basic starting point for a dashboard. And then of course the flip side of that will be Kibana for getting our logs. So let's go to Kibana. So here we have Kibana. I had actually already logged into it, so it didn't actually ask me to log in, but you can see again up there, there's my test user. And then we can go straight to visualize and make sure things are showing up. And that's why I'd previously logged in, so I could set up the default index and stuff. And in a moment, it should give us any logs that have been passing through our Kubernetes cluster. And here we go, so random log, whatever's at the top there. And you can see it does a pretty good job of breaking down the logs. We also have, let's look at Harbor next. So we'll see if we can log into Harbor with my test user. And you can see I'd already jumped in and made sure it worked. And we have a repository I created, which is Alpine. So that's logging into Harbor itself. I could do a Docker login. Username test, password. Helps if I can type. Docker tag, Harbor cluster 1, and then we'll do a Docker push on this. And this should push it up to my Harbor registry, which it is doing. It's not too big, it's 88 megs, so it shouldn't take too long to get up there. What else should we look at? I think, what am I missing? Spinnaker. So let's bring up Spinnaker cluster 1 demo. So Spinnaker is the CD tool from Netflix that everyone is raving about. You can see that logged in. Because I've already logged into some other stuff via OIDC, I'm sort of able to piggyback on that. Not much to see in Spinnaker though, obviously, because I haven't actually set anything up. But let's have a look at Harbor. So that finished uploading. So if we refresh here, we should see now we have Ubuntu as well as Alpine. And now we have it. This is platform operations, right? This is taking a Kubernetes cluster and actually making it useful and making it so we can perform those operations tasks. When we get woken up at 3 AM, you need to be able to look at logs, you need to be able to look at metrics, you might need to be able to bounce around some things, and this is bringing those tools to us. And it is authorizing them back against our enterprise Active Directory or LDAP. Thank you so much for watching.